welcome to Dev Factor. Today we have an exciting tutorial that's going to be a little bit quicker paced than my other tutorials. Today we're going to cover the fundamentals of the Java programming language in just 15 minutes. So for starters, you'll see I'm making a new project on Eclipse. A project is just a way of organizing all of your code files into one place. And now I'm going to be making a class, and I'm going to be calling that class car. And a class is a representation of both state of data, which is referred to as a field, and of actions that we do on that data, which is referred to as methods in the Java programming language. So it's kind of like a blueprint. So we're going to make another one. We're going to make a class called Ferrari. And when we have the Ferrari class done, we're going to go back into the car class and we're going to put some documentation. First, we're going to do a multi-line comment. Now, comments are not read by the compiler, so they're only for the programmers and to aid the programmers in understanding the code. Next, we're going to do a javadoc comment. Notice the two asterisks instead of one asterisk. This can get compiled into HTML and turned into a web document using the javadoc tool. Now, you'll notice we have a version and a author tag. Those are very important for the javadoc tool. Next, we're going to build a constructor. A constructor is responsible for setting up the defaults and creating all of the objects that you put as fields at the top of your class. You'll also notice that we have a single line comment, which is represented by two slashes, and a multi-line comment represented as two asterisks after a dash again, which we called the javadoc comment and is interpreted by the javadoc tool. Now we're going to make a static final integer called speed and set its value equal to 1. You only want to set the values of static final integers outside of the constructor. So an integer is a data type that holds whole numbers, and the reason we're using uppercase is that's a common naming convention for static final variables. Static means you can only have one instance of it, and final means it can never be changed once it is instantiated. Now we're going to have a private final int that is not static. This means that we can have multiple instances of this particular int. Now this private final int is going to be called break speed, and it's going to represent the speed it takes for us to break from 60 to 0 in our car. And in our constructor, you'll notice we set the value of break speed equal to 1. This is the purpose of the constructor. Now we're going to go below the constructor next, and we're actually going to make getter and setter methods. Getter and setter methods are an important part of most Java classes, as they allow other classes to interact with each other without being harmful to the classes that are surrounding them. So by making a setter allows us to, from another class, say, hey, we would like this class to switch the value stored in, for example, break speed. And the parameter there is speed. It's a good convention in Java to prefix all parameters by the and to prefix all fields by my. This helps prevent you from getting them confused. Now we set our break speed equal to the break speed passed in through the method. Now see, if we didn't have getters and setters and you could just access the fields anywhere, for example they were all public, it would be very easy to accidentally change a field in a very large program and not understand why it was not working. And now I am switching the code so that it follows the naming conventions I've just described. Remember, parameters start with the and fields start with my. So again, final data cannot be changed, and static data we can only have one copy of. I'll give an example of that pretty soon involving a swimming pool. So now that we have a setter, we can call the cars. When the car method, which is the constructor, sets up the value of my break speed, we can say that that is setting the default. And then we can make another method called getBreakSpeed, which returns the current break speed to whoever is requesting it. Now we're going to put our javadoc in the Ferrari class as well. Remember, this type of documentation is important for you and it's important for other developers, but the compiler does not care about it. Now we're going to make our Ferrari extend car. This means Ferrari inherits all the attributes that car has. We can say Ferrari is a car. So Ferrari will get its own constructor, but won't have to write as many fields in, and won't have to write as many methods in, because it will have a lot of shared fields and methods from the car class above. This allows us to minimize code reuse. It makes it a lot quicker to write software. Object-oriented programming, which is what this convention is called, is used very frequently in games where we have classes. For example, we may have an enemy, and all enemies may have a shared trait like health or speed, and we can inherit them instead of rewriting them. So now we made a main class. What is a main class? A main class holds a main method, and a main method is the starting point for any Java program. Whenever someone runs a Java program, the first method that will be loaded is the main method. Now we're going to print out hello world. Using the print line command, we print out the text, and then we print out a line break at the end. If we were to use just the print method, we would print out the text, but would not print out a line break at the end. So you may notice that there's a syntactic difference between them. It's just the absence of an ln on the standard print command. So let's create an instance of the car object. Let's call it test car. Now that that's up on the screen, we can say that main car has a test car. This is a composition relationship rather than an inheritance relationship. The Java developers, the developers of the Java language, say that they favor composition over inheritance. So now that we have our own copy of the car object, we can ask for its speed because we made a get speed method, or get my break speed. And you'll notice that using the Eclipse IDE, it will actually give us a shortcut to that method. And if we print it out, we will get the break speed. We also made a setter method, and I will do an example of how setters work. So we can call the setter method and we can switch that value. And the value of test car's break speed will be switched so that next time we print it out, we'll see the current value after the change. So here I'm printing out testcar.getBreakSpeed, and you'll see that it's changed to the number we set using the setter method. Now if you look above, you'll notice that it says 1, 2, 3, 123. It's not actually numerical 123, it's just represented as 123 because we used a print statement rather than a print line statement. And here I'm showing an example of what's called string concatenation. What we're doing is we're taking a string and we're combining it with another string. This is generally quite inefficient because we have to destroy the original string and create an entire new string. So you may want to look into the string builder object if you find yourself having to do this frequently. And if you ever have a typo in your comments and you're using the Eclipse IDE, you can simply roll your mouse over it and it will give you some good spelling suggestions on how to fix it. So our Ferrari, we're going to give it its own field, a field that the car object does not have. We're going to call this cost because Ferraris are generally quite expensive, and we're going to include the my in front of it as part of a good naming convention. So in the constructor, we set the default of my cost equal to 300,000. We'll assume this is $300,000, which seems about right for a brand new Ferrari. And now we're going to create another method. When we say public, that means anyone can access it as long as they're within the package. And then we say int means the method is going to return an int. We could also say string, and it would return a string. After that is the name, and in this case we're just returning the cost. So we're going to create a new Ferrari object, test Ferrari, similarly to how we created a new car object. And let's try to print out Ferrari. So let's do Ferrari.getMyCost. You'll notice that we get an error. See, what we did here was we created an instance of Ferrari. So we should be referring to that instance, so we're only getting one copy of the cost. Instead, we're referring to the actual Ferrari class and trying to get the value from the Ferrari class rather than our instance of the Ferrari class. Now this issue can be easily resolved by, instead of trying to print out the Ferrari object's cost, printing out our instance, which is testFerrari.getMyCost. And on the screen I'm putting down some details about this error because it's an error most people find quite frequently when they're starting out in the Java programming language. A good rule of thumb is that you cannot access a non-static variable from a static context. You'll notice when it's switched we get the proper output with no issues whatsoever. Again, this type of relationship where we instantiate an object inside of a method is called a composition relationship. On the other hand, the relationship where our Ferrari extended car is called an inheritance relationship. Inheritance is known as a is-a relationship, so a Ferrari is a car. Composition is known as a has-a relationship, so main car's method, main, has a test Ferrari, or has a Ferrari named test. We can also introduce logic into our code by the use of if else, and else statements. There is also an alternative called the switch statement, which is slightly more efficient if you have more than 3 statements in a row, and I would suggest looking that up on your own time if that interests you. But in this example I'm going to be using an if statement. So the syntax is if followed by parentheses, and whatever is inside of the parentheses is evaluated. In this situation we're testing our object testFerrari.getMyCost, so the cost associated with the Ferrari object against a number. If that returns true, we print out almost $500,000 on the screen. Now on the other hand, if that returns false, nothing will happen, unless we put an else if or an else statement right below it. Let's try an else statement. So what an else statement does is if the if evaluates to false, the else statement will fire. And so if the testFerrari.getMyCost is not greater than the numerical value that we put to the right of it, we'll instead print out cheap. We can also use loops. Loops are ways of allowing us to iterate through a section of code or a block of code multiple times so we don't have to rewrite that code. In this example, we're using a for loop. A for loop, we create an integer value, and then we iterate until that integer value reaches another value, and then we increase the value of that integer. We call the integer the iterator. Next up, we'll use a while loop. In this example, the while loop is going to always fire. While loops, as long as whatever is in between the parentheses evaluates to true, they will continually fire. Once it begins evaluating to false, they will stop firing. I hope this video was helpful, and I hope you now have a stronger understanding of the Java programming language. Although 15 minutes isn't much, that should be enough to get you started. If you're interested in more programming or game development tutorials, please subscribe to our channel. We have great, fresh new content out 2 to 3 times per week. Otherwise, if you have any questions or issues with the tutorial, please leave them in the comments section below the video.